Okay, hello everyone and welcome to Handmade Hero, the show where we code an entire game live on Twitch from scratch, no libraries, no engine. And basically, you know what? Honestly, it's pretty much going to be awesome. That's all we really need to say. I'm already starting to get that feeling that this game is going to be awesome. And so there's really not much more to say. Let's just start because we were doing a bunch of cool stuff yesterday, and now is the time when we can sort of finish up a bunch of the things I think that we had started down the road to doing. Well, I don't know if we'll finish up, but we'll do some kind of interesting other things that I've been wanting to do for a while. And so I don't even want to take too much time to preamble this. I just want to get going. It's programming time. I ate like half a bag of chocolate chip cookies before the stream, which is not a good idea. So I'm a little bit wired right now, and that's fine. But anyway, if you have pre-ordered the game on handmadehero.org, you should have gotten a link in your email. And that link has a zip file you can download with all the source code in it. What you want to do is download the source code for day 53, because we're on day 54, and so you unzip the previous day's source code and you can code right along with me. So if you're doing that, do that. Now is the time to do that. All right, so if I remember correctly, we'd just gotten to the point where we'd put little entities in the world to represent all the walls. So basically now the entities, we made these little yellow entities there that are all around the side. Those are all the walls. And we now have a situation where, excuse me, where we haven't actually quite finished doing or figuring out exactly how we're doing our sort of like two-level and two-tier entity system, right? We have entities that are sort of in the field of view, sort of active entities that we want to consider at high frequency and to do like full gameplay on. And then we also have entities that are further away from the camera that you can't see and that aren't in the immediate vicinity of the player. And we want to allow those to run at a low frequency so that we can still simulate them and have rich interactions going on elsewhere in the world potentially that the player could experience the effects of later when they go there, but that aren't going to suck down a ton of CPU time if we want to scale the entity count up to really high numbers, 10, 100,000, who knows how many. So what we need to do is kind of continue down on that path. It's kind of fun to see him bounce up and down for some reason. So what we want to do is continue down that path and also put in, we have currently no spatial partition or anything like that. So also collision detection right now is extremely inefficient because we're colliding against all the high-res entities all the time. So even the ones that are like off-screen we're colliding against. So we need to start paring this down and making this, letting this coalesce into like a nice good system now that we sort of started on that path. And it is a little bit taxing for me to do, unfortunately, because it's weird to do this in like 1 hour chunks like this. But I've been trying to keep it mostly in my head. I page it out during the day when I'm working on other code, and then I try to page it back in now. So we'll see. Hopefully I won't make too many mistakes. So anyway, what we sort of started doing here is we sort of started making it so that as the camera moved, we had this set camera call. And what the set camera call would do is first it would go ahead and it would map out, so it would change the entity residence of any entities which were sort of were currently in the high frequency set and no longer need to be simulated at high frequency. And then we would go ahead and go through all the entities that were in the like outside of that high frequency set and might need to come back in. And one of the things that I was saying yesterday, and I think is probably true, just I'm looking at how this is going and whether I want to deal with it or not. And you'll notice that we still have never come up with a real good idea of what would even be in a low entity, because we had dormant, low, and high. And really everything ends up in the dormant or the high entity for the most part. So really the only things that would kind of be in the low entity that I can think of are like movement timers or something. I mean, like the difference between a dormant entity and a low entity is just whether or not they would get ticked periodically on that sort of periodic update. So I'm kind of thinking that maybe we just have low frequency and high frequency entities. That's what I've been thinking. Because I don't want to overcomplicate something for no real benefit. So maybe we still would have the concept of a dormant entity, which is a low entity that doesn't really ever need to be ticked. But maybe we just don't ever have that, and that's fine too. I don't know. It's really hard to say. So I think what I'm going to say is let's just go ahead and make that change. Let's just go ahead and say that we just have low entities and high entities, and we don't have that third tier, just to simplify things because I haven't seen the need for it so far. And so I'll let that need reemerge if it turns out to be true. But if it doesn't, then we'll just count ourselves lucky that we've got one less thing to deal with, and that's that. So let's go ahead and remove those dormant entities entirely, right? And I guess I'm going to replace dormant everywhere that I see it with low, right? So I just got, that's all I've got now. So I can go through and do all of these. And then there's some places where we have dormant entity stuff that just goes away entirely, like here where we've got 2 of those. And the compiler should tell us about that just fine, I think. Yeah. So I've got rid of the low entities, and so now they're gone. And I think things should probably still work roughly the same as they did, and they do, so that's good. No problems there. There we go. And so now let's think about this a little bit more carefully. So I've got ways of adding entities now that are in here. And one thing that's interesting about adding entities is I think technically entities probably should always be added in the low state and then get moved to high, because most entities are always in the low state. Like when the whole world gets generated, everything will be in the low state, right? Nothing be in the high state. So really that high state is just for a limited number of things that are just right around, that are just right around the cursor, or right around the player, right? And so typically we would expect to have lots and lots of low entities and not very many high entities, right? So the next thing that I think might be a good thing to do is to start thinking about it in those terms where instead of having, like, I did this thing and I thought that was kind of clever, but the thing that I was thinking of is I wonder if it maybe makes more sense to already even now start to partition into high and low entity sets that aren't mirrored. So, you know, something that looks more like this, where we start to say that the low entities and the high entities don't map to each other. Like they're not one-to-one correspondences. There's a ton of low entities, and there's only a subset of those that are actually in the high set at any given time, right? And furthermore, one thing we could do, and I don't know, you know, like here's, I'm just throwing this out there. One thing that we could do that's kind of amusing is we could think of the high entity set as basically consisting of some fixed number of entities. Like we could say that there are always 256 entities simulated at high resolution or something, or always 64 entities simulated at high, I don't know, right? We could say that, and then the entities that are in that set are just however many entities, whatever the 256 closest entities are, right? So as you move around, it's just always keeping the entities sorted by whoever's close to the players in that set. I don't know if that's actually something I want to do, but I just thought I'd throw it out there as something I was kind of thinking about. It's like, oh, that's kind of interesting. That way we have like a bounded set, and we know that's always what we're simulating in terms of a fixed kind of thing there. Anyway, so yeah, so, you know, if we did it this way, then what I was thinking of doing is, so the entity residence would go away, right? And what would happen is something like the low entity structure would just have a writer on it that basically said, you know, where is the high entity, right? What's the high entity index? And that high entity index would tell you if it was 0, it means that this guy isn't in the high entity set. And if the high entity index was set to something, then it would tell you that the high entity was, in fact, present, right? And symmetrically, I could do it where you've got the high entity has a pointer back to its low entity as well. Now, I don't actually know if both of those things are necessary. It may be that we could make it so that that was not necessary. But it's just kind of an interesting thing to think about. Like, so that way we would just go, we'd look up our low entities when we need to move them to high. We just do that and record the fact that they're in there. And in the high entity set, when we're spinning over them, we grab the low entity that we want. If we actually need it, we grab that low entity out of the pool by doing just a dereference, right? So that's something to think about. Another thing that we could think about doing is that the high entity could just include the low entity in it just straight up. So in other words, we would copy the low entity data out into the high entity. But there's reasons why I think that could be dangerous. And that's because we're going to have people who simulate primarily on low entity, and I want them to kind of try and stay in sync. So I think for now, I want to go with the forward back pointer thing that just links them up. And then as we see how the patterns emerge And when we start getting into more like performance-oriented things, and we start to maybe care a little bit about whether that's a little too much to have these like references going everywhere and pulling randomly out of things, the random memory accessing patterns, then we can start to think about it, whether we need to do something different. So yeah, so there you go. So what I want to do now is say, okay, so let's go ahead and do that. Let's create things only in the low entity list, and let's start treating the high entity list a little bit more specifically, right? And so we've got this high entity list here, and we'll have a high entity count and a low entity count, basically, so that we basically, we kind of have two different ones. And I'm putting an underscore after this temporarily because I want to see everywhere that's used, and I want to think about it a little bit. And so now what we can do is we can say, all right, when we want to change an entity's residence, right, then really when we're changing its residence, I'm trying to think if we ever actually need this function again, or whether we want this to be more a make high and a make low, because we'll always know which one of those two things we're doing, if that makes sense. Let's take a look. Change entity residence. So get entity actually does have it parameterized there. Here, there. So those are, yeah. So I'm thinking that we probably want this to kind of change up a little bit, right? I'm thinking that we kind of want this just to be a make high and a make low. So basically, like there's a way of, there's something that moves a low to a high, and there's one that gets rid of the high, right? And you never really have to move the high back, right? Because I think that that would always sort of just automatically happen, because I think we said that we always keep that low state updated anyway. So really all we have here is we have a like move or move it, but make entity high frequency or something. And we'll get rid of this for now. Right? And we also don't really need this anymore for the most part, because all we know that you always have a low, and so if you got a bundle, you just check to see if high is not null. That's the only thing you would have to check for, right? So if I want to do make entity high frequency, I'm going to say which entity it is that I want. That's an index, obviously, into the low, so I guess we should start to call these low index, and that's probably something that I might want to start actually having a type for. Hard to say, but like an entity index type, just so people don't, well, people being me, don't make mistakes passing the wrong kind of index, right? So let's keep an eye on that, and if I do make that mistake, that would be a good indication that it's a good time to do that, right? I like how we still have implement this here, even though we already implemented it. Like I said, comments, always stale. So all right, so if we want to do this, we want to make an entity high frequency. What we need to do first is we need to go ahead and pull its low entity, right? So we grab its low index out like that. And then we need to check to see whether its high entity index is actually 0. Because if its high entity index isn't 0, that means it's already got a high entity and we don't care, right? So if we need to move the guy to high, then what we need to do is first assert that there's room for him in the high table, right? And if there isn't room for him in the high table, he can't move. And so one of the things that's interesting about that, actually, I guess we could also say, we could also go ahead and just make sure that that's always true. So that that's not true, we'll assert it as an invalid code path, right? And I don't know if we actually ever defined one of those. Handmade platform.h. Is there assertions in here? Yes, there are. But we don't, but we don't have them. So I'm going to go ahead and define that. Define invalid code path. And invalid code path is just something that I like to do, which is essentially an assertion that I stick, that always asserts, in some place that I never expect the code to actually get in practice, but which theoretically could happen, and that I don't want to create a bug at runtime, right? And so one example of this is that technically our game might not do all the things that it's supposed to do if we try to make an entity high frequency, but it's not able to because we run out of room in our high frequency table. But technically we shouldn't just straight up crash, right? Like, why not make it so that we just keep running, but everything's at low frequency instead, right? Seems fine. So I would say, all right, we've got our entity high, we've got our entity low, whatever that high index is. So at this point, if whatever that high entity count is, if the game state high entity count is less than whatever the array count is of the high entities, right? Then we're going to go ahead and say that it's okay to add it, right? And so now the high index is going to be equal to whatever the entity count was, and incremented so that we know the next one. You know, we're just taking a slot in our high entity thing. And then we'll go ahead and grab out that high, and then the rest of the function can proceed as normal, right? So all we did is just push someone onto the top of that high entity array, right? So that's all good. Now we're going to map this guy into the camera space. And again, also another thing here is it's important to point out. So this number pretty much has to be fixed. So this is not really a case where, like a lot of times we talk about garbage collection and automatic memory management. Is it bad? Is it good? All these other sorts of things. This is actually not what I'm worried about here. So this is not, the fact that I need this high entities thing to be a fixed size has nothing to do with memory management actually. It does happen to be nice because it means that our memory management will be fixed, and that's fine. But that's not actually why I'm doing it. The reason I'm doing it this way is because high entities are the performance cost. And so I know that I'm basically going to have a certain budget for high entities, right? I know that however many I can afford, and we'll find out what that is later, but however many I can afford is limited by the CPU time per frame I have to process them. So I can't just make this an unbounded array that grows. It has to actually be limited in a realistic way. So when we start talking about memory management and those sorts of things, we're really going to be focusing more on this array, which is going to hold lots of guys potentially, not this array, which is going to be limited to a small number of guys, which is, you know, 2d6, 512, something. Who knows how many guys, but however many we can successfully process at speed for whatever it is that we need to do. Okay. So we grab out the next high entity that we need there, and we do the same stuff that we used to do on it, which I think is fine. And now after we set all this stuff up, we can record the fact on the entity low, the fact that it has a high entity index, right? Which is that. So that's the thing for moving us into the high frequency space. And then if I want to do the opposite, like make entity low frequency, then I've got two choices. And this is largely, I guess this is really just about performance. I don't actually know that there's any other thing that would matter here about whether I do a free list or not, but you can see, I think I'm going to do it this way. We'll see how it goes. So what, oops, there's not going to be an if there. And also, I guess now that I think about it, this is wrong. It's okay if it's already got a high. So it's only that I wanted to insert a invalid code path on, right? That's like, I didn't want it. The high, if that already has a high, that's totally fine. That just means someone wanted to make something high frequency that was already high frequency, which is really not an invalid code path. That's probably something we'll just allow so that people don't have to check first. They can just say, I need this guy to be high frequency, and it will be. So we really only wanted to assert if we ran out of room so that we know, because we want to try and make our game so that we always do use the right number of high entities. So that's really what that's about. All right. So that is that, and let's make sure that that compiles okay here. Let's see. Okay. So then when we make someone low frequency, we're going to do the opposite of what we just did, assuming that the guy... oh, and that's backwards again. Yeah, it's if he doesn't have high entities. Yeah, a little slow today. A little bit slow. All right, so assuming that the guy does have a high entity index in this case, then I need to pull him off of that list. So he shouldn't be on the high anymore. And so what I need to do first is say, and I could pull this out here to high index, right? So if the high index is at the end of the array, then I don't have to worry about it. So if the high index is equal to however many entities there already were in that high entity list, right? High entity count. So it would be equal to that, I should say, -1, right? So if the high index equals the count -1, then all I have to do is just decrement the count, right? because it was the last one, so I just decrement it. But if it wasn't the last one, then I have to move it into, I have to basically fill the gap that's going to be left by closing that hole, right? So if you imagine we just have an array here, right? Here are my high entities, right? I've got 0, 1, 2, 3, 4, 5, 6, right? And then I've got my low entities here, right? And these guys are pointing into this in various ways, although hopefully not to this one because that's illegal. So I've got all of this stuff set up. What I want to do is say, all right, if I'm going to remove this guy, right? So he's going away. I don't want to leave an empty space there. We could decide to do that, which, now that I think about it, might actually be the right solution. Just mark it as not there, so that when we're processing through it, yeah, that's probably better, huh? Because you know that we want this to be a constant time processing, so we know that we have to support being able to process everything. Yeah, so why am I even thinking about this? Never mind. I take it all back. I don't have to do that at all. So we're just never gonna decrement that count. I think what I'll probably do is I'll probably just keep a free list. That seems like the most logical thing to do. I don't know. I'm so torn right now. You can see why I'm torn, right? Because we know that we're going to have some budget for processing a certain number of entities, right? And so, you know, let's say we can afford 256 entities. So when we're doing the processing of these, I feel like there's no reason why we shouldn't just skip ones that are marked as done, because we know we could have processed them if they're all filled. So we don't care if we pay the performance penalty of skipping one that's not there in the iteration, because it doesn't matter. We could have, we're saying that we had a CPU budget to process them if they were all filled. So it seems like that would be fine. And then all I would do is just keep a free list, which basically points every time you eliminate one of the high entities, you just add it to the free list. And so then when someone wants to take a new slot, it just pulls it off of the free list, right? So that seems like a pretty reasonable way to do it. I don't know why I wouldn't. But then the other thing that I was thinking of doing was saying, okay, when I pull someone off, I'll just take the last guy, whoever's the last guy on the array, and I'll move him to that slot, right? And then just reduce the count by 1. And the reason that's a little less janky, a little more janky, is because it does involve doing the copy here and then setting this guy's, whoever was pointing to this, right? Setting them to point to there. You know, it's like, I don't know, which do you do? They're both fine. And so normally I would do that if I wanted to keep the array compact for processing purposes, but I'm already saying that I need to, that the array is only as big as my processing could handle anyway at maximum. So that's not a concern. So it seems like, yeah, I don't know. I'll keep the array compact for now. Let's just say that we'll keep the array compact for now. I really don't know. That's just what I'm going to do. So assuming that we happen to be removing the last guy, then we're just done right away. Otherwise, we have to do the remapping. So otherwise, what we have to do is say, well, okay, who is the last guy then, right? We need to basically say whoever is the high entities, right? So whoever is the last one, and this is like, I guess, last index, last high index, right? So if we were going to remove the last high index, then we're done. Otherwise, we're just going to grab whoever that was. So that's high entity, last entity, right, is this guy. So we'll grab that last entity. We now need to romp him over where the other high entity was, right? And I guess what's one thing that's kind of interesting about this is we might have the high entity index as well when we want to make someone low frequency. So it's kind of a little tough to say which way we should be doing this, whether we should pass the high index here or not. But either way, we'll think about that in a second. This is kind of our whole or our deleted entity. This is our deleted entity, right? And so our deleted entity, he is at high entity's high index, right? So what I'm going to do is I'm going to go ahead and say that the deleted entity now equals whatever that last entity is, right? And then I'm going to say that whoever was, whichever low entity was pointing to him as his high entity, right? I just need to go ahead and tell him that it's been moved, right? So he has his high entity index, like so, equal to whatever our high index was, right? That is not what I wanted to do. That is not what I want to do. Low entity index. There we go. So this is basically saying the low entity that the last entity corresponds to. His high entity index now points at where we just where we just filled in the array. And in either case, I guess this always happens. So really, this is just if they're not equal to, meaning if we do have to fill. Now, in either case, excuse me, in either case, that entity low, the entity low's high entity index that's getting romped is always going to revert now to not having a high entity, right? Because it's become low frequency. So I think that's right. We'll have to step through that once to make sure I didn't typo anything up there. All right, so the get entity call. I think the get entity call, I don't even really know if we're going to have a get entity call anymore, to be completely honest with you. So we'll see who's actually using it. I'm not entirely certain. So yeah, I think get entity is basically just going to be, get entity is just going to be a thing about getting low entities. I think that's really all there is to it for the most part. Hard to say. Hard to say, indeed. So let's think about this for a second. But yeah, I think we really just don't care about that. So I think this is going to be, I think this is just going to be get low entity potentially. I think that's really all we're going to have. And I think you're not going to really do a get high entity call. I mean, I guess I could just supply both of them. And they are assumed to return like 0 if they don't exist. So it'd be something like, you know, low entity star result equals 0, assuming that the result is between the 0, you know, the first valid entity and the last valid entity. Then we'll go ahead and return it. Otherwise, we return null. So I'm gonna say that that's how this works. Yeah. So basically, yeah. I like that. All right. So let's go ahead and do that. So that's just low entities plus low index. That's how we get that result. We don't care about any of this stuff. That's not going to happen anymore. So that result goes there. And then we will go ahead and put those right here for now, and low becomes high. So that does that. And low index. I guess we could just do, make that just be called the index, so that those are symmetric. Sometimes it's nice to have them be symmetric. Okay, good. All right, so I think that should just about do it. So if we're going to add an entity, that now means that we're always adding a low entity, right? Entities are just, you know, they're just going to be low. And let's go ahead and assert here that the low entity count is less than the low entity array size. We will go ahead and initialize that entity. So we'll do it like so. There we go. And that will be it. And we don't have to change anything else. These guys basically add low entities, and I feel like with the entity index, these guys don't really need it anymore, I think, most of the time, because now entity index, and this is kind of nice, doesn't really mean anything to people. They don't need to know an entity's index anymore. It's not really important. In fact, to some degree, well, no, I guess you kind of still do need to know the entity index when you're doing that front and back pointer thing. So all right. So anyway, so these are always low entities that we're getting here. And this is get low entity. And there we go. So that's that. I think there's a little inefficiency baked into that, unfortunately. I feel like maybe we want to be returning pointers in some of these cases, but that's okay. No big deal. So let's see. Add entity. It's add low entity now. So there we go. Add low entity. And low. So this is just like that. And I guess I could also do this, like so. Okay. And you can see that I'm, this is the kind of thing that I do a lot. I oftentimes write code multiple times. I'll just go through it several passes. You can see it doesn't take me that long, and I'll spend a few times doing it. Put things in, remove things, pull them out. It's like, this is definitely the part where you're like shaping the clay and seeing what the maquette looks like, right? Before you decide to sculpt the finished piece. You just got to be willing to kind of go over things multiple times and like get them until you're pretty confident. And you need to do that actual work in there of trying different stuff until you get it, till it feels good. And that's really important. So I don't mind like the fact that we write and rewrite a lot of these things multiple times. Because like I said, as long as you keep those rewrites fast, they don't cost you anything and they end up producing a much more high quality result at the end. All right, so now if we're adding a player, again, we don't care about any of this stuff at all. So what we need to do here is just take a look at this, at camera following entity index. Assuming that equals 0, then we'll set it to equal to our entity index, which is fine. Let's see what else we got here. So now we're going to do, these are loops solely over the high entity index, right? And so this is just going to full on get those directly. High entities. This is just a nice straight loop because we're going to have to start making this sort of code is going to have to start being performant. So how did we get to here exactly? We have a move player. So we need to pass, I suppose, a high entity here, right? Because only high entities can move, right? We only have, this function only works with high entities. So we go ahead and do that here, I think. Well, let's think about this. So I'm trying to decide whether I want that low-high pointer thing, where they're bundled, because I had that, right? I'm trying to think about whether I want that. Like, do I want to keep using that or not? And, maybe I do. So maybe I do want that to still work for the most part. And this would just have in it the low index, right? Because you can always get the low index if you have a high, and you can always get the high index if you have a low. But you might not have a high, so you might not have the low index. So that's really the only thing that we need there. So we'll see. We'll see. Anyway, so I'm not sure if I actually want to keep this or not. We'll see, or whether I still want accessors on it or not. But what I do need to do is be able to compare these two. So I want to do is say this right here is the high entity index. This is basically the test high entity index. So we're just looping over those high entities to test to see if they're there. So we're going to go ahead and grab basically a high entity, test high entity, like so. We're going to go ahead and grab that out. And we know we can get the low if we need it, but we're just not going to get it right now. So then we go ahead and say, all right, and in fact, I guess we don't even need to do that quite yet. What we could do first is say, if the entity index that we're talking about here, if that test high entity is not equal to us, right? So this is whatever we are. So this is entity.high, whatever our actual index is. So I guess it's actually entity low, high entity index. So if the two indices differ, then that's how we know that we need to check, because that means it's not us. So because we don't collide against ourselves. So then we go ahead and grab that test high entity, and I guess we also need to grab the one to see if it collides or not. We could loft that up so that we wouldn't have to pull the low entity for every single person, but we might end up just doing that in a different way. Like we'll only enter people into the grid if they collide or something like this, right? Yeah, so test high entity. We've got its low entity index, like so. And I don't remember, when we did make entity high frequency, did we remember to put that in there? No, we didn't. So entity high, low entity index should always be equal to whoever created him, right? Yeah. So that's that. Let's see here. Low entities. It doesn't have an underscore yet. So we have test low entity. Don't know why I renamed it that way. I should just call it test entity low to keep it symmetric. Test entity high. There we go. And I guess I could wrap these guys into an actual low and high if I wanted to. All right, let's go ahead and do that. So if I do the entity structure, because I'm trying to figure out whether or not I want this to happen, right? Test entity, low index equals entity, excuse me, equals test entity high, test entity low. So there's my high, there's my low, and the low index I have to get off of the high, right? So it's actually this guy, and I could do it that way if I wanted to, like so. All right, so that produces the test entity, and now I can finish the rest of this routine, which probably would just work because it's already set up to work that way. When we do the hit entity index should presumably, well, what do we actually need that for at the end? We just need to see whether we need to do anything to it, right? Yeah, so we just need to see whether it wants to go like up or down or those sorts of things, right? And so we probably just want to, we could save the pointers there if we want, or we could just save the high index. I'm not sure which one. Or we could save the low index for that matter. So let's go ahead and say hit high entity index for now. So what we'll do is we'll say hit high entity index equals test high entity index. And we'll do that in all the places where we needed to actually remember who we hit. There we go. So in the place where we remembered who we hit, we now can say, all right, hit high entity index this guy. So if I want to grab his stuff out, we can go ahead and say there's the high entity, right? And this is the hit high, and that is get high entity. I don't actually need to do that. I guess I know that this is always full. Game state high entity index. Yeah, so I almost want like a direct one that does an assertion to make sure I'm not referencing outside of anything, but that doesn't do the bounds checking so it would compile out. So I'll have to think about that one later. I'll have to think about that one later as well. All right, so that would be that, and hit low would be like this, right? And it looks like we only need the hit low for this guy, so probably we could have just saved that. Maybe it was a mistake to save the high instead. Let's see, go. And that's low entity. All right, so those are done, and now we need to loop over our high entities, and that's totally fine. We don't need to check our high entities because we know that everything that's in the high array now is high properly. We are doing all the same stuff that we were doing before, but now what we want to do is we want to be able to, so this is a little bit tricky. This will actually change people's residences in this loop directly. And what I'm thinking is, I wonder, is this the place where we would always do it, right? Is when they come out here. Because if it was, we could actually bake this right in here. And I'm kind of thinking maybe that is what I do want to do. Essentially, the only place that you can have it happen is here. And the reason for that is it makes the iteration not tricky, right? It means that the iteration is pretty easy for us to handle, and we don't have to deal with it in any other way. So basically what we do here is we'd say we're looping over these guys, right? We're checking them, and if they're not inside the rectangle, then we go ahead and we pull them out. We pull them out by doing that swap that I was talking about, and we just don't increment the pointer. So the person that we swap into place, we just don't increment the pointer. So I'm thinking that it looks something like this, right? So we've got the high entity count. We loop over everyone there. We check to see if they're in the rectangle. If they're not in the rectangle, then we grab their entity low by just looking at the high entity's low entity index. So we've got it now. We already know the high index, right? It's this. So we just say this is our high index, like so. Get rid of that. So that's just a nice loop, very, very straightforward. We check the rectangle. This is the not very frequently. This won't happen presumably very frequently. Oh, well, it might, because I guess we don't set camera that often. But so we take a look to see if the high entity index you know, I take it back. There is one other case we have to handle. When somebody walks out of bounds, we will have to handle this. So maybe I just want these two routines to be like aware of each other so that the iteration is still easy. Because what I'm worried about is that iteration, this mutates the array, right? So the iteration, if it was just a naive iteration, would fail to work properly, right? So it's just something to think about. That's all. So yeah, so basically, like, let's say I call this here is all I'm saying, right? So this mutates the array, and so we wouldn't want to increment the entity index. But that assumes that we know, right? So it's basically, if it's in the rectangle, skip it. If it's not in the rectangle, get rid of it, right? But that assumes that we kind of know exactly how that removal function is working. And it's kind of, I don't like, you know, having that be so implicit in the code necessarily, and it would be nice if there was a way to kind of avoid that a little bit, right? And so, I don't know, like maybe the best thing to do there would be to kind of like sort of pair these guys together, right? Say, you know, make entities low frequency by area, right? And that does this loop, right? But it does the loop right here, and yeah, just so I guess offset and check frequency by area. There we go. And so we'll call that function, and these will kind of be coupled with the previous function so that they're in the same place in the code and they make a little more sense, right? And so this will just pass what that entity offset is, right? So that's the offset there. Let's see, offset check frequency by area, entity offset frame, like so. So this right here is what my offset's going to be. And this is the thing that I need to pass for the bounds for checking. So that's going to be camera bounds. And so we'll just do that. And that can still be, you know, that could be an inline, so it just still sticks it in there. But just so it's, you know, clear what's going on in these guys, right? Most of these could really be inlined for the most part. Well, this one might stay out. All right. So I think that is how I would like to do that. So everyone who's inside the rectangle gets skipped. Everyone who's not just gets deleted from the high entity array. And then this has to be over the high entity count. So, and that's much better. Going over the low entities, it's the same thing, only now instead of doing change entity residence, we're calling make entity high frequency, right? And that is that. And I think that's really all we need to do, oops, about that. So we do need to do this and say we're not going to try to move anyone if their high entity index is already set, because we know that they already have a high entity, right? So this is only if their high entity is set to 0. And then, oops, got to pass the game state. There we go. And then we need to reserve our 0th entity in both places. So we do need to do a add entity, and we need to do a basically a reserve a slot in the high entities. So high entity count equals 1 as well, so that basically we never get below that 1, because the high entity index of 0 has to be reserved for the null entity. So what else we got to do here? For controlling entities, so an entity that you're controlling, we do want that to always be high. So I'm trying to think, though, exactly whether we want, how exactly we want to do that, because it's basically this move player function that ends up wanting to do that. So I'm not sure exactly how we want to handle this. So what we want to do, I guess, is we want to first say, whatever the player index was for controller, let's check to see what that is, right? So we've got low index for the player, right, is coming out of this thing. And so what we want to do is say, if the low index is not equal to 0, or, yeah. I guess we could change the sense of this and say if it is equal to 0, right? So assuming that it's equal to 0, that means that we are checking to see whether or not this controller is going to start controlling a player, right? And that would do this. So we'll say ended down, and the index equals add player. So we're going to add the player, game state player for controller, entity index. That all looks good. No weirdness there. And then in the case where we aren't, then we're going to do the move. And the move does require that the player be in high. So this is one case where we would have to say, you know, make sure that the entity is actually a high entity. So I don't know if I want to still do the thing. I guess if I just have a get high entity that forces entities to high, that would do it. And it looks like, I'm trying to think of whether this guy even cares that much. It looks like this guy does also use the high. So yeah, so I feel like what it's looking like to me is what I want to do is have is maybe have entity. Maybe when you call get high entity, that is the thing that returns an entity struct that has both pairs and the index in it. That seems to make some sense to me, because that's looking like the usage pattern, right? That's the time when you actually do that operation. So I think maybe that's the right way, right? Yeah. So in this case, when we add it, it's totally fine. We don't need to turn him to high. But when we actually move him, we would need to turn him to high. And so that's the controlling entity equals get high entity, right? And so when you call the get, it's a little bit weird to call it get high entity because you're actually passing a low index to it, right? But it seems like you never really get an entity by its high index. That's really just something that you use when you're looping over them in processing. So it's hard to say. It's hard to say how I want to do that exactly. So we'll think about it some more. But that's basically what that would do. So get high entity would actually look like this. You would pass a low index, right? And the way this would work is you'd have a result. You would first do a make entity high frequency, like so, right? You would always do that on the guy when you call high. And you would then, in fact, the other thing you could do is say that make high frequency could return the high frequency pointer. Although in the case where one already exists, maybe you don't necessarily want to. Hard to say. But we could say that this works like this, right? We could say that if it already has one, we just return it, right? So we've got high entity, entity high equals 0. So in this case, we do entity high equals this. Right. So there we go. And we would do that here as well. But in this case, it'd be entity low, high entity index. Okay. So if we have a high entity index already, we just get it. If we didn't have one, then we make sure we create it like that, like so, and then we return the entity high. And that way, in here, all I have to do is say, okay, the result is going to have the low index. It's going to have the low entity, which is just whatever the game state low entities plus the low index is. 5-minute warning. Man, so close and yet so far too. And then it's also going to have the high entity. So there we go. So we've grabbed those. That's all good. And I guess I'll allow it so that when you call get high entity, we will allow it where you can call it with something that would be out of bounds, and it will just it will silently fail on that. So maybe I just want this to be an assertion. Maybe that's the right thing to do. Because it seems like you should never be getting a high entity that way. But we could change it later to say that you can pass a 0 here and get 0 back, right? Get a 0 pointer back. I don't know which one we want to do about that. I really don't know. So we'll find out. To do. Should we allow passing a 0 index and return a null pointer? Maybe. Who knows? Okay. So, let's see here. Let's see. So when we are looping over the test entities, and you got to get the low, yeah, that was a little bit janky. I didn't love that. All right, so get high entity. So when you're controlling entity, we pass that. Gets the high entity, that's fine. This gets the high entity as well. And this could just basically look to see whether it has a high pointer. Assuming it does, it goes ahead and uses it. Let's see, the low index has to be between those bounds. This is going to loop over the high entities only, right? Because it doesn't actually need the low for anything. Sorry, it always needs the high. And so that is pretty much it for that. This is the high entity index here, like so. There we go, high entities plus high entity index. And then our low entity is just going to be gotten from the high entity itself. So high entity dot low entity index. Okay. And that's it, right? So there we go. Now I'm sure that's going to crash horribly because I did so many random things there. That's way too many to have not made some mistakes. But that's basically what I want to do. And I think I want to do one more pass over it because I feel like I want to clean up that entity handling there. So let's see. Oh, right. So this guy needs to check. So that would be a case where it would argue for the thing that I said, where it should just check the bounds to see. And so I don't know. Like, let's do it because it looked like that was sort of something I had wanted to type in. So we'll let it happen, and we'll see if it's good or not. All right. So we are not working properly there. We did not properly create our other high entities there. Why did we not create that? Why did we not handle them? Oh, we still haven't done our wrapping yet. So we still have not fixed the wrapping problem. If you remember correctly, this thing here is not correct yet. which is, yeah, we don't have time probably to do that stuff today. But let's just take a look and see if that, no. Did I do that right? I thought that would have been good enough to fix it, but it might have been a different problem because we still, if you remember correctly, we still have the problem here of making entities high frequency when we're doing the checks. We don't support the wrapping properly because we said we weren't going to support wrapping, and this would actually fail on wrapping. But I do not actually know why we didn't get the entities when I fixed that problem. It also looks like he's not in the right position when he moves there. So we've got some stuff we got to deal with here. So let's go ahead and start our debugging pass. Probably won't finish it, but we're compiling now, so that's fine. And we can finish it tomorrow. In fact, it won't be long, right? Because it's tonight Thursday, so it's actually a morning tomorrow. So it'll still be fresh in our heads. Okay. So let's go ahead and take a look briefly at what's going on here. Maybe I will go ahead and step through that set camera call as a good example of seeing how things are working. So let's go ahead and check this guy out. We don't care about that function because we don't have any high frequency entities yet. So what we want to do is take a look at our low frequency entities. Presumably the problem here is the min tile max tile thing. Yeah, so that's the wrapping problem. So let me go ahead and set those to 0 temporarily so I can see what was actually going wrong, why the entities weren't getting added to the high frequency list. So let's assume, I guess the easiest way to do that would be to say, let's assume that we're going to add everything, right? Everything gets added. So here we go. We go through here, say make entity high frequency. We take a look at its low entity. We see that it does not have a high entity, which is true. We see that we have room to store it, which is also true. We assign it a new index, which is the first index, which seems also correct. We grab its entity high pointer. We initialize its entity high pointer. Let's see what happens here. Make sure that's reasonable. That seems reasonable to me. And off we go. Okay. So that all seems pretty reasonable. That looks like it's going to make a bunch of high entities to me. So what happened here? Was it our rendering call that failed? Let's find out. Ooh. We are hitting our invalid code path at make entity high frequency. Oh, so we added more than 256 of them. Oh, right, because we were adding all of the entities that were in the world entirely. Although that does seem a little bit odd. Because there shouldn't have been more than 256 entities in the world total, correct? Am I right about that? So I kind of feel like this is getting called more times than it should have. For example, if the high entity index was not being set when an entity actually goes into high frequency. It looks like it is, so I'm not sure why that would be, but let's take a look. So if we go into the game state and take a look here at the high entities list, right? So let's see, looking through here, let's see what kind of numbers these are. Low entity index 150. Wow, we have a lot of low entities. I guess I take it back. How do we have that many? That doesn't sound like the right number of entities. How many screens did we create? We only created like 2 screens, right? So how many walls there? That doesn't make any sense. That feels like there's way too many low entities in the first place. You know what I'm saying to you? Like it feels like add wall got called way too many times. But let's find out. So let's see what happened there. Let's see. So if I come in here, right? We're going to run to here, start the program fresh. If I look at my game state, I've got one low entity, which is the reserved null entity. I'm going to run through here, and I guess I'll run through here one time first. So let's run through here once. Low entity count is 48. Run through here again. And what's our count now? 94. So there's only 94 low entities. So this just looks like a typo bug where I'm incrementing my low entities. That's the problem. I'm still doing array count on these guys, but we actually have a regular count now. So this should actually be low entity count since we only have a certain number of those, and the same is going to be true for any of these guys. Yeah, okay. So let's see if that's better. I feel like that should be better. Won't fix the problem, or it will fix the problem. So now we are back to parity at least, and that is a good place to leave it. Still got a few more things we really need to do here though, because we got to start doing our spatial partition, but it's getting better. It's definitely getting better. I think it's in better shape now. Things are starting to shape up. The reason that I like this is because we can start to see things breaking off into nice little chunks, right? I can start to see this looking like an actual engine that I could be happy with, right? Because we're starting to have nice little loops. Like I can imagine writing a nice fast loop that's a thing that goes through and checks things for whether or not they need to be moved out of the high frequency set like that. And I can see making a spatial partition that accelerates that, right? The same is true for this other loop down here. This one, I think we could do the same thing for, right? So yeah, I'm feeling pretty good about this. I think we're getting to the point where this is probably what it should be. We've just got to push a little further and just kind of massage everything out into exactly where it's supposed to be, but I'm pretty happy about this. I don't expect there's probably going to be too many questions since this was mostly just code rearranging stuff. Sometimes that's what you have to do. Excuse me. But either way, it is time for the Q&A. So let's go ahead and start the Q&A in case there are questions, because, well, sometimes there are questions even when you don't expect there to be questions. So let's go ahead and do the Q&A. Please prefix your question with Q:, so I can see it. And also try to keep it for stuff we did today and stuff that we did in previous days, so that we're basically like, staying on topic. If you want to do off-topic chat, that's cool. Just do it pre-stream, so come like 15 minutes before one of the scheduled start times, and that's when we do off-topic chat. Is there an advantage of making the size of the low entity and high entity arrays a power of 2? Probably not. That was just me being a programmer and always picking powers of 2. We don't know what we'll do with these. Like, I don't know how big these will eventually be. These will be based entirely on performance. We'll be seeing how many high level entities we can support. I'm guessing it'd probably actually be fairly high at the end of the day, but I don't know. We might have a lot of complexity in how we do our simulations of them, so maybe it really won't be that many. Whereas the low entities will actually be quite huge, probably. I'm imagining that low entities plus like the properties, like however we decide to store low entities plus their properties will account for most of our game memory, is what I'm assuming. So yeah. This is a third-person game, right? Yes, it is a third-person game. What process would you have gone through for creating the controls and movement if this were a 2D side-scrolling platformer? No different, really. We haven't done the controls yet, though. So you probably got to wait till we actually cover those. Like right now, we just have a stand-in thing, right? We've got like a stand-in thing that moves the guy around, but that's not really like what it's going to feel like, because we got to do animation first and integrate those two things together to see exactly how we want it to feel. But yeah, we wouldn't really do all that much differently. Our collision detector, like basically right now, gravity only happens when this guy jumps, whereas with a platformer, gravity's more of a concern, more of a going concern. But otherwise, it's really mostly the same code. It's not that much of a difference. Do you feel today will be rewritten during optimization? Yeah, so again, all we're doing right now is getting all of our stuff arranged so that we know what our spec is, right? It's basically so that we can see, here is the layout of the code, here are the APIs to everything. And then we can go do, okay, now let's go write the final collision detector, let's go write the final renderer, let's go write the final, entity system, and they'll all be based on exactly this work that we've done here in the first, 2 or 3 weeks, which is what we're doing here, is all about getting that out. And so it's giving, basically you just need some substrate to start working on those systems, because without a substrate, you're working on the systems in isolation and they will be bad. And you'll have this huge problem when you go to try and bring them together. You'll realize they don't mesh well. And so what you want to do is make a simple version that meshes well, and then start iterating on the systems themselves to get them up to where they need to be. I don't know if it's been answered before, but did you consider large fixed point integers for both entity types like Tom Forsyth seems to prefer, instead of having the swap between floating point and the high frequency entities? So I don't necessarily think there's... So here's the thing. Being able to do everything in floating point has a lot of advantages, because really things are always set up for doing... Almost every platform now has 4-wide floating point that's fast, right? And it's usually faster than fixed point, because fixed point usually takes 2 operations to do things that floating point can do in 1. So I like to have everything work on floating point locally around the camera. That's the way I like to do things. Now, that's not to say that Tom is wrong about what he's doing. He may be right that that's a good system for certain circumstances. That's not the way I like to structure the code. So the way I structure the code, that would be strictly slower if I did large fixed point integers. But the way he structures his code, it might be the other way around, right? So what I like to do is I like to have everything operating at in floating point at full speed for everything that you can see, because you always can, right? And then the only time that I convert things out to integer to store them, that's like the slow path, and that's done separately. And so you can already see we've gotten to the point where we've basically done that. Like I've already done that step. So like the move player code that used to work in the other space is now entirely done just all in float. So we can optimize this really well now. We'll be able to make our collision detector be entirely float based. And then all we do is at the very end, after all the computations are done, we just map it back once. And that's basically free, right? So this way I feel like it's kind of superior than trying to use large fixed point integers for actually doing computation. Because if you do that, you can't go full speed in your main loops, which I feel like is not a good idea. But Tom may have a different opinion about that, and so you should ask him about how he would structure these sorts of things with large fixed point. Wouldn't it be a bit easier to keep a list of empty entity slots to add them there instead of always moving and changing one of the pointers? I don't know. Remember I said I wasn't sure which one I would prefer. And so I just did one of them. I think it doesn't matter. I think neither of them is better. I think they're just the same. The reason I chose this one in my head was just because it's less complex, because you don't have to then have the concept that entities are marked as empty. So when things are looping over them, they don't have to constantly check, is there actually someone here or is there not someone here, right? So that's why I did that. It keeps the complexity in the deletion code, which is what's creating the complexity, instead of spreading it out to all the code. So I felt like that was a better choice. but we'll see. Are you familiar with slot maps for game object storage, and do you think you'd use them for this project? We use them for our engine. I might be, but I don't know the term slot maps. Can you describe it? And then I can answer definitively. So I'll have to give you, of course, I'll have to give you 20 seconds to answer because it's going to be a delay of me asking you to describe the slot maps, and then you have to answer, and then I can see it on the Twitch chat. Somebody describe the slot maps. Describe the slot maps. Nobody wants to describe the slot maps. Well, unfortunately, I can't really say whether I think I would use slot maps if I'm not sure what you mean by slot maps. So there's that. Hello, Garlando Bloom. Any thoughts on controls for HH on controllerless touchscreen devices like tablets? No, not really, because I've never had fun playing games made for controllers on tablets. So I'm a little bit like, I am wary of doing anything like that because I've never seen it work well. Now, that doesn't mean after we're done with the game we couldn't go, hey, I guess the new project on Handmade Hero is to see if we can get it on an iPad in a way that doesn't feel awful. And maybe, you know, maybe we could do that. It's certainly, like, I'm thinking about it in my head, I think it could be possible to do what I want to do with the game on a tablet, I guess. But I don't really want to think about that right now because I don't play games on tablets, so it's kind of an afterthought for me. But it's not to say that it wouldn't be something fun to do later, so maybe we'll do it. I could get an Android tablet in here or something. So. Pseudonym 73 says, I think a slot map is just an implementation of handles, doubly indirect reference through a table. So I don't know if we'll ever have to do that. I suspect we probably won't need to do that. Obviously, you want to avoid that if you can, because doubly indirect references are slower than direct references, so unless we had a really good reason why we needed doubly indirect, we wouldn't. But, you know, if we need to, we need to. Will Handmade Hero always be 20 scale feet tall? No. Eventually he will be scaled properly, but we don't really have any need to at the moment. What am I drinking? Water right now. What I call a slot map is an array that can have arbitrary empty slots, and each slot has a virgin number for self-validation. Yeah, it doesn't seem like something we would necessarily need, but we might for transient entity stuff, so we'll see. We might have something like that, but I don't know. Yeah, so it's a weird to call that thing a slot map. It just sounds like a handle. I mean, it's like the old Macintosh operating system, right? It's like everything is a pointer to a pointer. I'm not sure why you would call it a slot map, but yeah. Like I said, that's just like a technique. That's like, you know, will we be using linked lists? Possibly. It depends if we need a linked list, right? And so, yeah, we'll use a slot map if we end up in a situation where that's called for. I wouldn't really consider that a major design decision, though. That's just a tool. Like, that's like a hash table. Sometimes you use it if the thing calls for a hash table, right? So I don't know. So we might have something like that in there somewhere, but I wouldn't say it'd be like a major feature or anything, right? It's just a little thing you do. All right. Have we concluded? I see no more questions. I see no more questions. I'll check for another few seconds to see if there is another question. No? Anyone? All right. So I think we are done. The stream has concluded. So we will call it. We are almost at the point where I'm happy with the high-low entity stuff. But like I said, I want to do one more pass. So tomorrow morning we will kind of go through and bolt a little bit more of this down, and I'll probably move, I'll probably start moving things off into a separate file now that I kind of have what I expect from the entity stuff, happening. I'll kind of calve that off because it's starting to actually become something in its own right. So that's what we'll do tomorrow morning. Since today is Thursday, if I'm not very much in error, it is, in fact, the time flies. So tomorrow, 9 a.m., bright and early, it will be breakfast programming with Casey. I may even have my breakfast with me. I don't know. Maybe not. I'm not going to promise something like that. I don't know if I'm going to have my breakfast with me. Maybe I will, maybe I won't. Right? Who's to say? But point being, yes, of course I want to stop debugging. But point being, I would love to see you here tomorrow if you are so inclined for another day of programming here on Twitch. 9 a.m. tomorrow morning when we will sort of tidy up our entity situation. And then I don't know what we're moving on to next. I guess the thing that we're moving on to next is I think I'm going to add some entities and add some hit points and stuff like that so I can start to maybe balloon that out a little bit. I don't know. Really hard to say. Or we could move on to animation and save the rest of the entity stuff for a little bit later. We also got to do 3D. It's all some, yeah. So many things, so many good stuff, so many good things on the horizon. So anyway, I hope you join me tomorrow for the end of the entity system stuff. If not, then I will see you back here on Monday, 8 p.m. Pacific Standard Time, standard schedule on Monday. Either way, it has been a pleasure coding with you, as always. If you would like to follow along at home with the source code, if you pre-order the Handmade Hero game on handmadehero.org, you will get a copy of the source code, and you'll get a link that you can use to download the source code every night, as well as the test assets that we've been using here on the stream. Those all come with it. So check that out if you're interested in following along. We also have a Patreon you can subscribe to if you want to support the video series. And we have a news and forum site to check out if you're trying to follow along and learn from the series. It's a good thing. It's got the schedule on there. It's got an episode guide with past episodes that you can go to kind of catch up or review old material. It's got coding resources where people have ported the game to other platforms and stuff like that. It's kind of cool to check that out. If you're trying to follow along on Mac or Linux, it's really, really handy because people have already done ports that you can look at. And we have a coding discussion board where you can post questions, and I answer questions on there, so do other people. It's a pretty cool place. Or if you just want to talk about the series, that's the place to go. So that'd be a great thing to check out if you're trying to learn from the series. Hope to see you all here again tomorrow, 9 a.m. Again, and if not, I'll see you Monday at 8. Either way, thanks for showing up, and hope to see you back here real soon. Yeah, I guess that's it at 9:20, 10 minutes early. Well, good night, everyone.